Okay, so we're looking at angle of elevation as compared to the slope. What does angle of elevation mean? How is the slope related to it? So we do have to use some trig. And that trig ratio that we're going to use is the tangent ratio. So you can see in the try these, we're calculating some tangent ratios and then some angles, just like we did in the getting started for this unit. So you do have to make sure your calculator's in degree mode if you've perhaps changed it or cleared your calculator. So tan of 26, tan 26. Close the bracket. If you don't close it, it's okay, but in future calculations, we may need to do other operations, so it'll be important to close the bracket. So you might as well get used to it. And then let's go to 3 decimal places, so 0.488. Okay, next one is inverse tan. So that means this is really finding the angle that has this ratio of the opposite over the adjacent. So then you press the second key or the shift key. Now remember, so in my calculator, because it shows the word tan, I put it in like that. So I'm going to go shift and then tan. So you see the inverse, the -1, and then 1.45. Close brackets. And that's an angle. We'll go to 1 decimal place, 55.4 degrees. Now, if you have an older, no, not an older version of the TI, but if you have a scientific calculator that doesn't show the words tan when you press the button, then you have to put the value in first. So you would have to put 1.45 in, and then you would go shift key, tan key, and it will calculate it for you. Okay, so it does depend on what kind of calculator you have. Next one on the right, tan of 78. So we're finding the ratio. So tan of 78. Again, if you have an older calculator that doesn't show the ratios, then you put 78 first and then press tan. So that one is 4.704. Let me just check. 705. If we go to 3 decimal places. And then the next one is second key, tan key, 1 divided by 2. So if it's given as a fraction, just enter it like a fraction. And then that's 26.6 degrees. Okay. All right. An application here. Leo is installing a guy wire on a telephone pole. That's a wire that helps hold up the pole. So this is the wire. The wire needs to be anchored 50 feet from the base of the pole. The wire must be attached to the pole at a height of 30 feet. What is the angle of elevation with the ground? So it's labeled here, but angle of elevation is always horizontal, the angle from the horizontal up. Okay, so you look out from your line of sight and you look upwards to the top of whatever object, in this case the telephone pole, and it says the angle of elevation of the guy wire. That's what we're trying to figure out. So it's this angle here from the horizontal up. So we are given the height and the horizontal distance. So they're asking you to calculate the slope. So 30 over 50, and that reduces to 3/5. So what is the angle of elevation? So slope, here's something to know. The slope is going to, of the hypotenuse of that right triangle, okay, that line of sight here, or the guy wire here, is going to be the same as the tangent ratio for whatever angle is formed there. So just be aware of that. And so a slope we've already figured was 3/5. So to get the angle by itself, remember when you're calculating an angle, you always have to press the second key, or depending on your calculator, the shift key. Okay, and so you need to see that -1 if your calculator actually shows words in it, otherwise you won't see it. And then we're taking the inverse tan of 3/5. So if you see the word tan on your calculator, you're going to go shift or second tan, 3 divided by 5. Oops, that was 2. 3 divided by 5. Enter on it. It's 30.964, let's say. Just check. Yep. Okay. So that's what the angle of elevation is. Okay, so it's from the horizontal upwards, and so it's the tangent ratio. If you remember back to Math 10, tangent of an angle is equal to opposite over adjacent. So in this case, that's the rise over the run, okay, which is the slope of the line. Okay, so the angle elevation of the guy wire with the ground to the nearest degree is 31 degrees. Okay, next one. Bev makes handcrafted kites. She is testing a new kite. She looks up along the kite string. So she's here. Notice how there's a little gap from the horizontal, because that's where her string is. So I'll just do a little stick person there. And so from her line of sight up to the kite, that is actually along the string, okay? And she's found that the angle of elevation is 20 degrees. So from the horizontal up to the line of sight is 20 degrees. So what is the slope of Bev's line of sight? So how is the slope related to the angle of elevation? So we'll go over to the next page here. It says, what is the slope of Bev's line of sight? So we'll look on our diagram again. So we're not going to include the 6. We're just going from that dotted line. That's really her line of sight is there. So that's 91, and the horizontal is 250. So that doesn't reduce. Let's convert it to decimal form so that we can compare it a little bit easier. What is the decimal value of tan of 20? So tan of 20 is 0.36, and it rounds to 4. Oops. Okay, so this is a rounded value, and so is, well, the other one, the previous one, is exact to that decimal place, but basically the slope of the line of sight, the string, is the same as the value of tan of 20 degrees. So how are the slope and the angle of the elevation related? So the slope equals the tangent of the angle of elevation. Right, so I guess I'll put the full word there. So if you know the angle of elevation, then you can calculate what the slope is. Vice versa, you can calculate what the angle of elevation is given the slope. Because we could then, if we didn't know 20 degrees, we could go inverse tan of 0.364. So second tan of 0.364. And you'll see to 2 decimal places, it's 20 degrees. So it's almost exactly the same. Okay, so that's the end of the lesson. So now do the practice and then do the mid-chapter review. before going on to section 6.6.